Hi students, good morning to you all. Last class you all learned about rounding off and significant figure, how you can round off a number and the rules which is used to round off a number. This thing and all you have learned last class which was taught by our Selena ma'am. And you all know about the fundamental quantities and derived quantities which I have gone through our first class. Fundamental quantities means which cannot be expressed in terms of any other quantities. So what is meant by fundamental quantities? Quantities which cannot be expressed in terms of any other quantities. Example you can tell length, mass, time. These are the example. Length means we cannot express this length in terms of any other quantities. These all things you have learned. And derived quantities means which can be expressed in terms of any other physical quantity or base quantity or fundamental quantity. For example, if you are choosing area, you all know area of this room. If you are choosing the quantity area, this area is a derived quantity. This area we can say in terms of a base quantity, like area means length into length. So area means what? Length into length. So this length is a fundamental quantity. Area is what? A derived quantity. So area, it is a derived quantity which can be expressed in terms of fundamental quantity. Length, fundamental quantity, area is what? Derived quantity. So this is what we have gone through. We have gone through in our last sessions and all. And today we are going to see a new topic, which is what? The dimension of physical quantities. So dimension, it is one of the very important and useful topic. In exam also there must be one question from this topic, dimensional analysis. So first thing, dimension of a physical quantity means what? So you see, we can write the same example you can tell velocity. This velocity you can write in terms of what? In terms of some fundamental quantity. It is a derived quantity. So this derived quantity we can represent in terms of what? We can represent by using fundamental quantities. This velocity we can represent by using some of the fundamental quantities. If we are adding some powers in these fundamental quantities, we can represent a derived quantity by using what? The fundamental quantities. You can see the page number 29. Page number 29. The dimension of a physical quantity are the powers to which the units of base quantities are raised to represent a derived quantity of that quantity. So page number 29, you can see the definition, the dimension of a physical quantity. The thing is, this velocity is a derived quantity. This velocity you can represent in terms of fundamental quantity. Displacement 1 time. So this is a full formula. You can go through page number 10, page number 10, there is a red color table. Many formulas are there. You have to learn all these formula in your lower class also. You have learned this formula. So velocity means what? Displacement by time. So this displacement, velocity means what? Displacement by time. This is the symbol we used for displacement and time. So velocity is a derived quantity. We can represent this derived quantity by using what? The powers. We can add some powers to the fundamental quantities to represent this derived quantity. That is what? Dimension of a physical quantity. So displacement by time. This is displacement means what? A fundamental quantity. Time means a fundamental quantity. So we can add powers and represent what? This derived quantity velocity. I will tell how later when we are solving some problems. You will understand more about this. It is very simple topic. So all the derived quantity. There are so many derived quantities. You can see some of the derived quantities which is given in page number 30 on table 1.11. Table 1.11. Area, volume, density, acceleration, momentum, force, work, power, energy. These all are what are derived quantities. These derived quantities, all these derived quantities which is representing by using this 7 base quantities. All the derived quantities you can represent by using this 7 base unit. This is a basic unit. Length, mass, time, current, temperature, luminous intensity, amount of substance. You know, this luminous intensity means it is a term which is used in light topic, optics topic. So these are the basic quantities. These quantities we can use to represent the derived quantities. These 7 base quantities we can use to represent what? Derived quantities. So here all these 7 quantities, these 7 basic quantities we can tell these are the dimension of a physical world. All the derived quantities in the physical world, all the derived quantities we can represent by using these 7 basic quantities. We can represent the area. Example, area you can represent by using length into length. This is what. So you can represent the area by using what? Length into length. So all these 7 basic quantity, when we are using the dimension, when we are using this dimension of a physical quantity, we use square brackets to represent our quantities. So length is a basic quantity. To represent the length, we use capital letter L inside a square bracket. Inside a square bracket. So mass, it is a base quantity. We can represent the mass by using the letter M, capital letter M inside a square bracket. Then time, so T you can use inside a square bracket. Then current here it is given A, ampere. SI unit of current is ampere. That's what you can use A inside a square bracket. Then temperature unit is what? Kelvin. You can use K inside the square bracket. Then luminous intensity, it is what? CD. CD means candela, unit of light, which is already discussed. So you can use this CD inside a square bracket. Then amount of substance, we can use mole inside a square bracket. So these are the basic quantities. These 7 basic quantities we are using to represent the derived quantities, and these are the symbols we are using to mention this dimension of a physical quantity. And these symbols, always remember, always you have to use the symbols inside a square bracket. Next is so now you see, I will show you some example how you can derive, how you can find a quantity, a derived quantity by using this concept dimension of a physical quantity. For example, velocity. First, velocity. We know the formula for velocity. Velocity is displacement by time. Velocity is displacement by time. So, what is a symbol used for displacement? We know displacement means some length. So you can use L inside a square bracket divided by time. Time means you can use the symbol what? Capital letter T. So now next step what you can do is L. This T you can take it upside down. So here T power 1. When it comes upside down, it will change T power -1. Now you can write these two quantities in one single square bracket. So L T power -1. This is what a dimensional formula for velocity. This is a dimensional formula for velocity. Like this, for all the derived quantities, we can find the dimensional formula. Another one example, acceleration. You know, acceleration dimensional formula, we can find you see, acceleration formula is what? What is the acceleration formula? Change in velocity divided by time. So change in velocity divided by. So change in velocity divided by time. Now it is a derived quantity. Change in velocity means it is a derived quantity. So you have to derive that also. So acceleration equal to change in velocity means what? Formula. What is the formula? Displacement by time. So displacement by time. Here already one more time is there. So into the time. So this is what? How you can derive a quantity. You see, acceleration is a derived quantity. You can write the formula change in velocity by time. Now here change in velocity is also a derived quantity. So you can mention this derived quantity by using a fundamental quantity. So displacement by time, and we are adding this time here. Now write the dimensional formula. Again, displacement means what? Displacement means what? Length. So you can use L divided by time, T. Again one more time, so T. So now what you can do? Take this T here. T power 1 is there. T power 1 is there. So T power 1, make it 1. So you can write L divided by, put it in 1 square bracket. So T power 1 plus 1 plus 1, 2. So T square. Now you can write now take this T square upside. So what will come? L T square. When it goes up, minus 2. So you can write the dimensional formula in a single bracket of L T power minus 2. So this is a dimensional formula for acceleration. So like that, by using this 7 basic quantity, what are the 7 basic quantity? Length, mass, time, temperature, current, luminous intensity, then what are? Amount of substance. So by using these 7 basic quantity, you can derive all the quantities and you can find the dimensional formula like this. So this is just 2 example. Now next topic is page number 30, 1.8.2, dimensional variables, dimensionless variables. In that word it is there. In that word it is there. You can see. First one is dimensional variables. Dimensional. Dimensional variables. In that word, meaning is there. Dimensional variable means quantity which possess what are dimension as well as it has some variable values. For example, you see velocity, length, you can take length. It is a quantity. This quantity has some dimension. Now, this is a dimension we are using for what? Length, L. And it has some variable values. Suppose we are measuring something. We are measuring the distance from one end of this room to another end of the room. So when you are measuring this length, maybe you will get some how many centimeter? Maybe some 10 feet. Yeah, near about you will get some 100 centimeter. So that 100 centimeter means what? It possesses length. Length possesses some variable values. Always we indicate the length 5 centimeter, 2 centimeter, 3 centimeter. We are indicating some values. So that is what here it is saying, dimensional variable. You can see the page number 30. Physical quantities which possess dimension and it has some variable values. Understand now? The second thing is, one more example, velocity. So velocity, already we have found the dimensional formula, L power T power minus 1. So it has some dimension. Also, it has some variable values. You can tell you are moving when you are riding a bike. You can tell that I go on that road with 60 kilometer per hour. So we are indicating some variable values. So that is what a dimensional variable, a physical quantity which possesses dimension and variable values. Next one is dimensionless variable. Dimensionless variable. Dimensionless. In that word it is there. Dimensionless means what? No dimension. But it has some variable values. For example, here it is given a refractive index, damn. Refractive index. Refractive index given, strain given, about elasticity, specific gravity given. So refractive index. You see, I'll tell about this refractive index. Light is passing from one place to another place, and when it is passing from air to this room, from outer side to inside the room, the light ray which bend. You already learned about the refraction and all. So that measurement is what we are saying, refractive index. That measurement, how much it bends. That measurement is, so in water how much it is bending, in glass how much it is bending. So in glass you can say 1.5, no unit of 1.5. So it has some variable values, that is, but no dimension. No dimension used for this refractive index, but value is there. This is a value. Like strain, elasticity, some of the material, rubber band, it stretches more, steel. So this and all, it has some variable values but no dimension. Next one is dimensional constant. Dimensional constant means dimensional constant. Dimensional constant. So in that word again it is there, dimensional. So dimension, some physical quantity which possesses dimension and it has some constant values, not variable values. The value will not change. Some fixed values, some constant values. That is what of dimensional constant we are saying. So there is a dimension as well as constant value. Example here given, gravitational constant. Gravitational constant, the dimensional formula is m minus 1 L power 3 t power minus 2. This is a dimension for we are using for what? Gravitational constant. And some value is there, 6.674 into 10 to the power minus 11. This is a constant value, universal gravitational constant fixed value, 6.674 into 10 to the power minus 11. That is what we are saying, dimensional constant. It has some dimension. This is a dimension used for gravitational constant and constant value, 6.6474 into 10 to the power minus 4. Like that, another example, Planck's constant. Planck's constant also has dimension m L square t power minus 1. M L square t power minus 1 t power minus 1. This is a dimension used for Planck constant, and the constant value is there for Planck's constant also, 6.63 into 10 to the power minus 34. Here minus 11. Planck's constant. Planck's constant. Planck's constant 6.63 into 10 to the power minus 34 we are using. 10 to the power minus 34. This is what a dimensional constant. There are physical quantity which possess dimension and water. It has some constant value. And the last one is dimensionless constant. Dimensionless constant. By the numbers. Dimensionless constant means that where it is there no dimension but constant value. Quantities which possess what are no dimension but it has some constant values. Pi, you know, pi constant value. What is the value? 3.1. No dimension. Like a Euler's number, he means Euler's number, then all the numbers. So, this is what dimensional variable, dimensional less variables, dimensional constant, dimension less constant. You have to know before going through the next section, principle of homogeneity of dimension. Okay. So, dimensional variable means what? It possesses what are some dimension quantities which possess dimension as well as what are variable values. Example, then dimensionless, no dimension but it has some variable values. Dimensional constant, it possesses some dimension as well as what are it has constant value. Dimensionless, no dimension but constant values. So my dear students, you can see page number 29 and 30. Example is there, velocity. So you can find out the dimensional formula for velocity and acceleration by using the symbols which we have gone through now. So all of you take your notebook and textbook, page number 29. You can write the dimensional formula for velocity and acceleration. This is your homework. You can ask any doubt anytime. Thank you for all.